All right, ready? Why is this not going there? All right, pay attention. There's not much time, and then it's the weekend. That's what. Then you can start talking. Okay. 24. Normal distribution. Okay. So this is where we're gonna spend a lot of our time and energy on moving forward. So when you think normal distribution, I want you to immediately think of a bell curve, okay? That's what normal distribution is all about. It is symmetric about the mean. So the mean is the middle. Okay, remember vertex is the middle for a parabola. The mean is the middle for our bell curve. And watch this, it's a probability distribution. Symmetric about the mean. So what does that mean? Shh, no more talking now, guys, okay? Data near the mean are more frequent, okay? And if you move away from the mean, there's less. So this is almost like, imagine like a histogram where most of your data is in the middle. And it will appear as a bell curve. Watch this. I'm going to give this a different color because this is important here. Mean indicates the location of the curve along the x-axis. So example, if your mean is 100, then if you go up the x-axis, you picture 100, and your bell curve is going to be situated around the 100. Okay, so 100 is like the peak where most of my data tends to gravitate towards the 100, and then it tapers off towards either end. And then here's another color for this one. The standard deviation indicates the scale of the curve along the x-axis. And I don't have room to add anything to that, so I'll just leave it for now. A large standard deviation will stretch the curve, flatten the curve. This should not be new to you. I already gave you a heads up on that, right? It's a flatter curve, it's more spread out. And a small standard deviation will squeeze the curve, so it will be a steeper curve if that's happening. Reminder that symmetry indicates that half of the values are below the mean and half of them are above it. So in a sense, percentage-wise, if this is your mean right here, if the mean is in the middle, you'll have 50 here and 50 on the above it. 50% of data will be below it, 50 above it. So if the mean height for Canada is like, let's say 160 centimeters, half of the people will be taller than 160 and half will be shorter, more than likely. Okay. Examples of data that follow normal distribution is the height, weight, migration of birds, baby birds hatching in the spring, right? There's a peak. There's some that hatch early, not a good thing. A lot of them don't make it, right? Then there's the peak, and then there's some that are very late. So that's the same thing here. The time of the year that does, like deer, are in heat when they're able to become pregnant, amount of traffic around a certain time of day, number of COVID admissions. Do you remember what was said all the time during COVID? We wanna the curve. We wanna flatten the curve. Do you remember that? We didn't want, the hospitals did not want all the cases to happen at the same time. They wanted to have this happen, right? Okay, so COVID, we wanted to flatten it. So what does that mean? What standard deviation would we want to have? We wanted to have a great standard deviation, a big standard deviation. So here are the properties of a bell curve. I need you to fill this in. All the numbers, I'm going to fill this up with numbers. Okay, so we know that in the middle is our mean. And sometimes it has the letter mu. Some textbooks have that U looking. It's also our mean, okay? And we know that if we look at our mean, that's the center. I'm going to give that a highlighter here. This is the center. It revolves around the center. We know that if we move out from the center to 1 standard deviation on either side, we have 68% of data will fall within 1 standard deviation. If we go 2 standard deviations to either side, so there'll be 4 in total, right? There are 4 standard deviations in between, we have 95%. Just copy things down for today. I will have to explain this a couple of times. And if you go from the middle and you go out 3 standard deviations, okay, you have 99.7% of our data usually falls within 3 standard deviations. And I can guarantee you that after today you will start hearing this when you listen to the news, or when you listen to different people talk. They will talk about standard deviations. Okay, I'll just make a note here. This is the same thing as this, which is mean. Okay. Another note here, so just a couple bullets. Curve never touches x-axis. The percentages represent the probability. Another way of saying probability is the likelihood. Let me zoom into that because some of you are having a hard time reading that perhaps. Of data falling within range, within that given range, okay? So this is just a box on the side because sometimes students are a bit confused, like what are all these new terms that you're throwing around. That's what that means. So given that our bell curve is symmetric, if it's 68 here, what is this little chunk here going to be, you think? 34. This is actually bio. If you go higher level, you see this as well. Maybe some of you have seen this already. 34, 34. Okay? And it turns out that if you then go out even further, this stretch right here is 13.5%. Your homework is going to be to have a very nice bell curve with all these percentages written in it. Okay? So it's 13.5, 13.5. If you were to add up these 4 sections, you add up to 95. You can double check that on your own time. Then this little sliver here, it's very small. I tried to make it a little bigger. 2.35%. Okay, can you see that? 2.35. That's why I'm saying it out loud. Let me see if I can zoom into that. 2.35%. So if you add up these 6 sections here, you would get 99.7%. Which means that this sliver here, the little sliver you see, you have to work really hard to make that sliver appear, right? It never touches. You will have 0.15% on this tail, okay, this tail, and the other tail has 0.15 as well. If you add up the tails and everything in between, that is 100% of our data, right? So 100% is the whole bell curve, but most of our data falls within 3 standard deviations, like from here to here, okay? So that is 99.7%. One more thing. When it comes to z-scores, you're going to see this in university or college as well. Something we call the z-scores. The z-scores I will give you the definition of the z-scores before I give you the number. What are z-scores? How many standard deviations away from the mean? This is worth highlighting. You need to understand what that is. It comes back later, but I want to introduce it here already. What are z-scores? It tells us how many standard deviations we are away from the mean. So what's the z-score going to be right at the mean? It's going to be 0, because you're not at all away from the mean. You're right at the mean. Okay? And if you go to the left, one standard deviation, it'll be -1. It'll be -2. And then you have -3. On the other hand, so if it's negative, we know we are below the mean. If you're positive, you are above the mean. Okay? So my height, where would I be, you think? Would I be positive z-score or negative z-score? I'll be positive z-score. I'd probably be somewhere over here, right? In terms of my height? Okay. Anything, I need to highlight this part. I need to highlight a few things here. Different color for this one. A normal distribution follows the 68, 95, 99.7 rule, which is called the empirical rule. Okay? In bio, a lot of things follow normal distribution. Okay? Just in nature in general, it follows the 68, 95, 99.7 rule. A larger standard deviation results in a flatter curve. It's more dispersed. Dispersed data. Inconsistent. Nothing changes, okay? Whatever you knew about standard deviation stays the same. A smaller standard deviation is a steeper curve. Clustered around the mean. Consistent. Clustered, right? Bunched up, if you want to call it that way. Do a deep dive later on Google Notes LM. The total area or probability under the curve is always 1 or 100%. And I'm going to leave it here. So your homework is to have this bell curve. Okay, homework. Bell curve to study sheet. All important info should be on there. And maybe you might put too much stuff on there. I'd rather have that than not having enough. So if you need to erase later on, go for it. That's going to be part of your homework. The other one is going to be, I have no room here, I'm going to give you an AC to take home. And that AC is going to have everything to do with what you did on whiteboards today. So you bring that in on Monday. If you want marks, we're going to correct it together.